Okay, so this time we'll go through Excel Solver, which is way more powerful than the GoalSeek in that it can actually go through multiple variables to get a function to work. So here we have a 3D graph. So this would be something like z is equal to an equation that has both x and y in it. And I tried to make it something complicated enough that, yeah, it's probably worth it to get the solver out if we want to find something like, where is this a maximum? We can do, where is it a minimum? Where does it cross zero? So that'd be a lot of places where it would cross zero. Okay, so let's try this guy out, the solver out. To find it, you actually have to load it in, go to File, Options, and it is an add-in. One little thing here, be sure and hit Go, not OK. Hit Go. There's one more screen that'll pop up. Check the box next to Solver, and once that's in there correctly, it's going to show up underneath your Data Analysis tab, right there in your ribbon next to Analyze. Okay, so here we are back in Excel, and we're going to go ahead and try out that new solver function for solving where this three-dimensional equation would go to zero. So just like before, I'm going to set up some cells, only now we have more than one input. So it's not just X that we're going to be changing, it is both X and Y. And like we did before, we'll just start with, I don't know, some random value in here. We can try a couple of different starting values and see if we get different answers out of it. That could be an interesting thing to do. And then this time we have a function, and this function has more than one variable that it's dependent on here. So it's going to be a little bit trickier. And Solver can actually handle 2, 3, 10. It can handle a ton of different inputs. So that's a really neat thing that Excel is able to do. Okay, so here's our equation, equals cosine, and we'll assume that these guys are in radians. So I guess I should have just made that in pi or something. So I'll say x times y plus x squared plus y cubed plus 5. Okay, make sure I have that in there. Xy plus x squared plus y cubed plus 5. So that's a complicated enough. And we want to change around these two variables until we get our function here to find a maximum value. And if it's a cosine function, all of that is just inside cosine. You can wonder what would our maximum be. So theoretically, the maximum should just go to 1, right? Because cosine is something that's the max it'll get to. Okay, so here we go. Let's go back over to data, and we have our solver package uploaded here. And this time our set objective, so that is this function that we just put in. And we have an option of either trying to find the minimum or a specific value or the maximum here. And we're going to do that. So notice this is plural. We're going to be highlighting multiple cells. So we're going to change both X and Y. And I could highlight quite a few cells here to change in order to get this to solve. Okay, so here's what we're trying to set the objective. Let's go ahead and solve it. And what do we have? 1, yay! So, and it makes sense that 1 would be the maximum of that function, right? Because it is cosine. And there's an x and y value that would create that. And you'll see that the x and y it found are close to the starting values I gave it. So I started it out with 5, and it found some values close to 5. If I copy this over, Control C, Control V, and then maybe I start it at -5 instead, and we could try out the same thing and see if it finds the same answer. That would be, and a lot of these will probably have multiple solutions. So This one I graphed out in Mathematica. So it again, it always helps to graph it out so you can have a good starting value for these numerical solutions. So here we were able to reach that same value again, but this time we got to that value with some different values of x and y. So be warned, there's going to be multiple solutions that work, but at least we're getting that consistent maximum value out of it. So that's the solver. That's the solver function.